On number 40, it asks you to find all the complex roots, leaving all your answers in polar form with the argument in degrees, and then gives us, on my example, find the complex fourth root of negative 25i. So let's remember this notation. It's usually x minus I y. So I is always with the y. So in this case, we have 0 minus 25i. Okay, so knowing that, we now need to find our radius and angle, and after we find that, I will tell you why we found that. So our radius is always, Pythagorean theorem, where r is equal to 0 squared plus negative 25 squared. So our radius is equal to 25. So let's graph that. Okay, so our x is 0, and our y is negative 25. So that'd be down here. Theta. So since it is on the y-axis, you can't just do tangent inverse of y over x. You just have to think about it, hey, that's 270 degrees. So yes, our angle equals 270 degrees. The reason you can't do y over x is because x is 0, and any number divided by 0, that's an undefined, so it just wouldn't work. Okay, so now that we know our radius and our theta, we're going to use the formula for finding complex roots. It's z of k equals n, which is the number of roots we're looking for, of our radius, times cos of theta over 2, theta is our angle, plus 2 pi k, or I like to do 360k because 360 degrees. So 360k over n plus I, gotta run out of room, but it's basically sine of that exact same thing. So since I ran out of room, I'm just going to write it like that, and I'll come back and fill it in. Okay, so now that we have our halfway written equation, and we have parentheses, let's fill in our n, looking for fourth roots. So we have 4 square root of 25 times cos of theta, theta was 270 degrees, divided by our n, which is 4, plus 360k over our n, which is 4, plus I times sine, I'm gonna run out of room again, 270 divided by 4, plus 360k over 4. And then we would have 2 parentheses to close it. Okay, so now we can pretty much reduce this, and reduce this, reduce this, and reduce this. Okay, additionally, we can actually reduce this, and it becomes the square root of 5. So we have cos of, cos of 135 over 2, or I think it actually wants you to put it into decimal, so that's equivalent to 67.5, plus 90k plus I times sine of exactly the same thing. Okay, like that. Okay, so I keep running out of room, but yeah, that's the gist of it. Okay, let's put it right there. Okay, so lastly, that's your equation, and you'd enter this in, you'd enter this in, like, that would have a spot, that would have a spot, that, and that would have a spot. But it also wants to know what your k is. And it would have like 0, 1, ... And it wants to know what your last number is. So how you figure that out is we're looking for our fourth root. So there's going to be 4 of them. So 1, 2, 3, 4. That's how you figure out what your last number is. So say we actually wanted 5. Well, then it'd be 1, 2, 3, 4, 5. So it'd stop at 4. And that's how you figure out your k.